differentiation. So I'm going to do this example first. I think that'll make it a little more sense. And then I'll go back and do this top chart. Okay, so the idea here is I want to take the derivative of this equation. I would love to take this equation, make it y equals something, y equals whatever, bless you, and then take the derivative of it. The problem is I can't. Try it. So I can't get y by itself here. Like if I try to isolate this y and this is squared, if I try to square root this one, this will have a square root, and it just doesn't work. So there's a way we work around that. It's called implicit differentiation. So you're going to take the derivative of everything in here, including the y's. And when you take the derivative of the y, you're going to multiply by this dy dx. I'll try to explain why. You can really get by without fully understanding at all what you're doing, really. But I'll try to explain why. So if I take the derivative of 2y, I took the derivative of a y, which means I need to multiply by dy dx. So let me try and see if I can explain like what you're doing. I can't solve this for y. I don't know how to get y by itself. But there is a world where that's possible. So we're pretending we were able to get y by itself. It's in there somewhere. And then it's a chain rule piece. So like your y is your big guy. I'm sorry. Yeah. Your y is like your little guy. The 2 is the big guy. So you brought it down, left the y alone, you reduced by 1. And then the y is like a little guy. We don't know what it is. We only know what that is if we can solve this for y. But we can't. So we don't really know what it is. But we take the derivative of it. I can like get to the derivative easier than I can get to the actual thing. Again, if you don't understand what I'm saying there, it doesn't matter. You can still get the problem. So I'm just trying to help. Take the derivative of anything with an x in it, just like normal. So this will be minus 15x squared. And then you take the derivative of anything with a y in it, you multiply by dy dx. So what's the derivative of 3y? It's 3, but you took the derivative of a y. So you multiply by dy dx. So what's like going on there is like y is like your big guy. Or I guess like 1 is the big guy. 1 times 3, reduce the power by y, and then you multiply by the derivative of the inside. This represents the derivative of y. That we can't know what it is, but it does in theory exist. So we can solve for this. I can solve for the dy dx. I don't ever really know what y is, but I can find what dy dx is. So from here, it just becomes like a big algebra problem. dy dx is the variable that you want to solve for. So I'm just going to do algebra and solve for it. So I'm going to get all the dy dx's on one side and everything else on the other side. So 2y times dy dx. I'm going to bring that piece over. So this 3 times dy dx comes to the left, but it has to be negative, right? You switch sides of the equation. That does not have a dy dx in it, so it's going to go to the right-hand side, but it's going to become positive. With me? Ish. Okay. Factor out a dy dx on the left. So you'll get 2y minus 3. And then we're trying to solve, remember, we're trying to solve for dy dx. We're trying to get dy dx by itself. We're almost there. What's the only thing I have left to do? Divide by 2y minus 3. And so then dy dx equals 15x squared over 2y minus 3. So I wasn't able to solve this original equation for y. I still don't know like what y itself equals, but I know the derivative is this. So I can kind of get to the derivative without ever knowing exactly what y is equal to. But that process is the same every single time. Whether you understand what I'm saying about like the imaginary y equals or not, like that process just takes care of it. Let me do number 1. Probably number 2 as well, because I think that's trickier. minus 3y squared, but I took the derivative of a y. So multiply by dy dx. Derivative of negative 2x is negative 2. I did not take the derivative of a y, so it just stays. X to the fourth, your derivative is 4x to the third. I did not take the derivative of a y, so that's fine how it is. The 2y, your derivative is 2, but you took the derivative of a y, so you multiply by dy dx. So that's the game. My first step. If you have a y in it when you take the derivative, you include the dy dx. If it doesn't, you don't. Now it's algebra. Question on that first step? So now I'm going to get all my dy dx on the same side, so you can choose which side. But I'm going to bring those over here, that over there. So I'm going to have 3y squared times dy dx minus 2 times dy dx. When I bring this over, it's negative. And then 4x to the third plus 2. Also at the same time, because I want to show you guys something that I'm going to do the same thing but the other way. So I'm going to put the non-dy dx's on this side and the dy dx's on the right. I just wanted you to see what happens. Okay, so in either case, I'm going to factor out dy dx. So it'll be 3y squared minus 2. And then over here, I'm going to factor out dy dx. So it'll be 2 minus 3y squared. You don't have to write down the right-hand side one. I'm trying to make a point, but the point doesn't really come till the end. Slower. And then divide, right? So dy dx, if I want that by itself, would be 4x to the third plus 2 over 3y squared minus 2. You guys agree with that? Are you getting the same thing? We're okay there? Well, if I do it here, divide by 2 minus y squared, I'll get that negative 2 minus 4x to the third over 2 minus 3y squared. Dx. So what I want you to see is that those are the exact same answer. It just depends which side you put your dy dx's on. But what do you notice about every sign here compared to every sign here? They're flipped, right? So if every single sign is flipped, it's the same number. We're going to prove that to you. Like 8 minus 6 over 2, what does that come out to be? 1, right? Well, what if I did negative 8 plus 6 over negative 2? I changed every single sign. Don't I still get 1? So very often you'll do, like this comes up when you're checking your answers. Like you'll get this, and people will go to the answer key and see this, and they're like, what the hell, I got every single sign wrong. Well, good, you're right. So just like making sure you understand that those are the same. And trying to explain the question. So questions on anything I'm going through right now? Yeah. So here's the problem with, technically, yeah. Here's the problem with y prime. 3y squared times y prime minus 2x equals x to the fourth plus 2y times y prime. Like, I think I'm good. I missed the prime. Or you write it, and then, like, you in a second, you're going to think it's a first power, and then you do this. And then, like, you might think that's it's very easy to write the prime and then like screw up because of it. I think the dy dx is like less likely to make you screw up, but it's not wrong. I'm taking no responsibility for your risk taking. Other questions? Okay, 2. Let's jump to a lot of levels here. We went right from like the most basic kinds you could get, which still could be the AP test. Like, this is a valid question. So now we got trig. And what else do we have in here? What rule do we have to use? Chain rule and product. So there's a whole bunch. We went from like nothing to chain rule, product rule, plus differentiation, all in one product. Okay. This is our big guy, the sine. And then xy is your little guy. So on the right hand side, we do have a chain rule. When I take the derivative of the little guy, what rule do I need to use for that? I need to use product. So I'm using chain and product at the same time. So product rule says take the derivative of the big guy and leave the little guy alone. So the derivative of the big guy is cos. Leave the little guy alone. So that's like my g prime and my f. And then I got to multiply by the derivative of the inside. Well, the derivative of the inside requires product rule, so that's the fig plus give. Also remember that you need, I'm going to write this incorrectly at first. Don't write down what I'm saying. Fig plus give. So what's f prime? 1 times y. So that's the derivative of the first thing times the second thing. But I didn't take the derivative of a y here. I just wrote it. So don't put the dy dx. Only if you take the derivative. Plus, flip it around. So give. So the derivative of g, which is, what's the derivative of y? That's dy dx. And then times f, which is x. Now, if you wrote this, I know you understand the calculus, but you're missing some algebra. What am I missing? So chain rule says you multiply all of this times all of the derivative of the inside. So what am I missing? I'm missing parentheses. I have to have parentheses here. Otherwise, I'm only multiplying by like the first part of the derivative, and then I'm like separately adding the second part. Does that make sense what I'm saying there? Why you need them? Okay. I'm not done yet either. What's the derivative of the right-hand side? Just 10. There's no fancy rules over there. So that's the first step. That's the calculus. That's implicit differentiation. Question on that first step. That's the hard part. This one's tough. Is that part okay? Now I gotta get dy dx by itself. A couple ways I could do it. I could distribute and work with it that way. What I've seen the AP test do a lot, and I think this makes sense and it's a decent way to show it, is let's divide by cosine of xy. And then what I'll have is y plus dy dx times x equals 10 over cos of xy. Agree there? I'm hesitant to say this now, but I'm going to anyways. Could I rewrite the right-hand side so it's not a fraction? Dividing by cosine is the same thing as multiplying by once. Secant. Cosine and secant are flipped versions of each other, right? So instead of dividing by cosine, I could write this as sec xy. Now, do I have to do that? Not necessarily. It depends on whether it's multiple choice or not. On the free response, it's not a big deal. But what I see coming down the road is I'm going to have to subtract this y. And if I have a fraction, that's going to require a common denominator that I just don't want to deal with. Well, now it's not a fraction, so now I don't have a common denominator. So that's like why I was doing that. And you don't have to. I'm just going to show you tricks as I go. Questions on that step to that step? So now, again, I want this by itself. So what would be your next move? I believe I would subtract the y. And then divide by x, right? So if I divide this by x, those cancel. And that's what I end up with. I'll do one or two of the ones in the actual workings. You guys help me out. How's this scene? Thumbs up. Totally with you. I get you. I don't need you anymore. You're useless. Thumbs down. Don't go anywhere. I need you. Thumbs in the middle. Don't flip me on.
You have to put in secant.
No. Do you have any to go through if I don't? trying to show you like a bunch of stuff at once. Okay, so let's say I don't. So then I'm going to subtract y, right? So I'll get that. So it's not impossible, but people mess this up a lot. So I'm going to divide everything by x. Well, when I divide this by x, I'm going to divide like every individual term by x. Isn't dividing by x the same as multiplying by 1 over x? So if I multiply this by 1 over x, where does the x end up? On the bottom. So this will just be 10 over x times cosine of xy. And this will be just y over x. Like, that's a perfectly acceptable answer on a free response. On the multiple choice, this is what I was trying to avoid. They might go a step further and say, well, I need you to common denominator. So if I've got an x in both denominators, what do I need over here to have the same denominator? I need the cosine of xy. When I write it on the bottom, I better write it on top also. If I combine the tops, I'll have 10 minus y times cosine of xy over the x times cosine of xy. Which is the same answer I had. There's like multiple answers. That's one of the things that frustrates students. Like go back and forth. Skill. Repractice. Does that help for JUS? Correct? Go ahead and look through. So today we're just doing 1 through, like the first part, 1 through. So 1 through 13 is what I want you to do. But go ahead and look through. Like, tell me what I can do. They're not easy. Pick one. 10. 10. Okay. So I would rewrite it first, like sine of 1/2 y. I think that's easier to see, like what the derivative of that is, because I don't need quotient rule really. It's just like a half times y. Okay. So what rule or rules do I require to take the derivative of this? Do I need product also? I don't. So product is like a variable times a variable. I don't have that here, right? So I just have chain. So the derivative of sine, the derivative of the big guy first, right? Is cosine. Leave the little guy alone, and then multiply by the derivative of the little guy. Well, what's the derivative of 1/2 y? 1/2 times. I took the derivative of the y, didn't I?
Oh, dy dx.
So I got to multiply by dy dx. Plus the derivative of e to the y. So what's the derivative of e to the anything? It's like e to that thing. But then I took the derivative of a y, so I multiply by dy dx. And then the right hand side's a little easier. What's the derivative of 4x? It's just 4. So if I factor out a dy dx, so I already have I have 3 terms, right? But aren't the, so my first step a lot of times, second step. I have, very often I have to get like dy dx on the same side so that I can factor. But they're already on the same side here. So I don't have to do that stuff, so I can just jump right to factoring. So let's take dy dx out, and I'll get cosine of, I can put y over 2 back now if you wanted to. It'll stay as 1/2 y. Times a Tell me if it's not. Where'd you get this? Why'd you do this? What doesn't make sense? Then I would divide by all of that stuff. So it's going to cancel on the right. And your answer will be 4 on top of that whole thing. I would imagine a lot of places would write their answer like this. So that you don't have like a fraction within a fraction. So what did I do to go from one to the other? Well, how did I remove the one? I doubled every term, right? So if I double this term, doesn't that make those go away? If I double this term, I get 2e to the y, and if I double this term, I get 8. They're both correct answers. Just helping you out like a multiple choice to be able to match it. What else? I might be wrong. I think these are pretty hard for students at first. 9? Dangerous.
Yeah, these little pieces.
Yeah. That ain't it. Alright. So, does that, a couple issues here. So let's start with, is that A or B? When they say ln of y squared, are you supposed to square the whole n of y, ln of y? That's B, right? So we agree on that?
Yes.
Okay. What about this one?
That's the. Yes.
A or B? B doesn't even make sense really, right? Okay, so let's make sure we're just writing it on the same. So ln of y squared. So I'm going to write it like ln of parentheses y squared. And then cosine of x parentheses squared, because I think that's just easier for most people to kind of wrap their heads around. Nothing dangerous yet, right? For what?
The answer key starts writing the dy dx and y.
Say it again.
The answer key, it starts writing dy dx and y. They just highlighted me.
Oh, they like switched on it.
Yeah.
Yeah. I mean, it does. Y prime is faster, right? But you're a little more likely to screw up, I think. Okay, so this is a chain rule. I should ask you guys: is that a product rule? Why not? It's not variable times variable, right? This is a chain rule, so the big guy's the ln. So what's the derivative of natural log? 1 over. And then I put the little guy there, right? So it's 1 over y squared. And then I take the derivative of the little guy. So what's the derivative of that y squared? It's 2 dv 2y times 2y.
Yeah.
So 1 over y squared. Oh boy. There we go. So 1 over y squared times the derivative of y squared, which is 2y. But then I took the derivative of a y, so I multiplied by dy dx. Okay? So I agree it looks scary, but I think if we break it down piece by piece, it's doable. Here, what's your big guy? The squared, your little guy's cos, right? We'll take the derivative of the big guy, so 2. Leave the little guy alone, and then multiply by the derivative of the little guy. So what's the derivative of cos of x? It's negative sine of x. Do I multiply by dy dx? No, why not? So then take the derivative of a y, right? Equals, what's the derivative of 1? 0, so it doesn't matter. And the derivative of negative got some simplifying I can do. Like this, I can rewrite as 2 over y. This 2y is really up here. And then like you have an extra y at the bottom and a 2 on top. So 2 over y times dy dx plus 2 cos x times negative sine of, I guess that's the only thing I can really clean up, equals negative 1 times dy dx. And now it's just algebra time. Now I'm just moving things back and forth, factoring, dividing. Not that I'm saying that's like simple, but the hard part I do believe is done. Can I go over anything else on those first couple steps there? So then I'm going to bring, well, no, I'm going to bring this guy over here. So I got 2 cos x times negative sine of x equals negative 1 times dy dx minus 2 over y times dy dx. And I'm kind of running out of room here, so I'm going to cheat a little bit. But I think you guys can see. So, if I factor out a dy dx, what would be left over here? It's like negative 1 minus 2 over y, right? You see what I'm doing there? Alright, I don't have room to do 2 steps, so I'm trying to show you a shortcut. Take out a dy dx, and is it this part that won't be left? And then what would I do with that? Negative 1 minus 2 over y. I would divide by it, so doesn't it just end up on the bottom of this? So that's going to be your answer. It'll be this. And, like all the other problems, let's look at the answers 17 different ways and make sure we understand. So what if I did... Is that the same thing? If so, what did I do?
Yes, my wife.
Yeah. So sometimes they don't want a fraction within a fraction, so that's an issue. I've got 3 terms there. So to get rid of this fraction, I multiply by y to make those cancel. Then if I multiply this term by y, I've got to multiply this term by y, and I've got to multiply this term by y. So that's how I got this. Is this the same thing? Is the red answer the same? So I've got 3 terms, right? What did I do to all 3 of them? I just changed the sign. Again, as long as I change the sign for every single one, it's okay. So that is the same. I'm just showing you different ways to write the answer. What's up?
Would you have to flip the 2y cosine of x to the sign on that?
This is all one thing. So this term is negative. So that's like, you know, by like 3 times 7 times negative 2 times 8. Like that's a negative number because it's positive, positive, negative, positive. This is positive, positive, negative. So it comes out negative. So I switch that.
One of them, it'll be fine.
Yes.
And then,
Even if you put like that would still be fine because you just added a negative to it. So now you just wrote a positive. Right? It's,
and if you had negative 1 times dy dx minus the 2y over y times dy dx, how come there's not 2 dy over dx? There's not 2 of them.
here,
Yeah.
so you did a distributive property just backwards. So like if I were to distribute that, that's where the 2 come from. And then I put that at the bottom so I go divide that. Okay?
Yeah.
Why we didn't just multiply the negative 1 and make the negative 2 ADX? Negative 1 times 2 ADX, why we didn't just make it negative 2 ADX?
You just don't want to write the 1 there.
Well, I guess it's the same thing when you divide it. Never mind.
It like
Never
no,
mind.
I want to point something out though. If I do that,
It's the same thing.
I know, but I wrote it for a reason. If I do this and I tell you to factor out a dy dx, people will grab those, take them out in front, but they'll just write like negative 2y there sometimes. Like they'll forget that there's a number here, so that's why I put it. But it is the same.
Yeah.
All right, I do want you to try. I mean, I want you to have some time to try on your own. Not me just like yapping up here. But these are tough. I mean, I understand these are tough. I plan to spend 2, 3, 4 days on this. We'll see how it goes. Do what you can do. Bring me questions on Monday. We'll rock out some more implicit differentiation. It's not a very good name for branding.